Hello, Assalamualaikum and good afternoon. It's still me, Dr. Shaiman. So we have reached at the last part of the power state analysis. We're going to finish the double line to ground fault. Okay. I'm so sorry for being too sleepy today, but we still need to proceed and finish this. Okay. So without further ado, let's go directly to the contents. Okay. So basically, compared to the other two faults, single line to ground and line to line fault. So this is the third one, which is the last one, which is the double line to ground. When we go for the double line, means that there's two lines who are grounded. That's very easy to understand. So double line for here, for the phase B and phase C is totally grounded here. Okay, when this kind of situation happen, means that when both two phases are grounded, means VB equal to 0 and also VC equal to 0. And the part is IA equal to 0. So this IA equal to 0. Okay. So this is the next clue for this double line to ground. Okay. We are still using the same equation, the same matrix as before. So this is the basic equation that we're going to choose. But here, the VA is here. They have the value of VA. That's why we remain only the VA. But for the VB and VC, because it's equal to 0, that's why here we just replace it with the 0 value. Okay. So here we can clearly understand that when we try to solve this matrix, then we get VAO equal V1 equal to also VA2, which is the VA over 3. So this is the next solution that we get. Then after that, using the same equations as mentioned before, so we're just replacing all the values here where the VAO and VAO, because it's equal to VA, okay, equal to VA. So this is the equation. So because the VAO equal VA2 equal to VA1, that's why all these three are the same value. Okay, same. All these three are same. Then while the others is remain there. Okay. So we already know the impedance is equal to this. It's very basic. I think you are not confused with this, right? So basically what we're going to do, we are going to inverse this matrix, the impedance matrix, to become like this. At the end, 1 over Z. Okay, 1 over Z0, 1 over Z1, and 1 over Z2. Then after that, we just proceed with the next solution. Okay, so this time we put the inverse of the impedance matrix for both sides. Okay, for the left and the right. So we just put here, and then from here, you know, it's identity, so it becomes 1 matrix identity, so that be like this. Okay, while the others is remain there. Okay, then after that, so we just again replace the value for the VAO, VA1 and VA2, so we get this. Then after that, replace the value for the inverse matrix of the impedance. So basically this is the thing. So we are going to solve this. Once we solve this, then we get this kind of output. Okay, we get this kind of output where basically here IAO equal to minus EA1 minus EA plus IA1 Z1. Okay, and over Z0. So while the IA1, so we're going to use the IA1 after this, and so IA1 is remain there. But for the IA2, when we are pressing the IA2 in IA1 function, so we get the minus EA plus IA1 Z1 over Z2. Again, sorry for my bad handwriting, so just accept. Then after that, we all know also same thing. So IA equal to IA0 plus IA1 plus IA2 equal to 0. This is basic equation like before. So we're just replacing all the IAO, IA1 and IA2. So where this is IA1, okay. Oh, sorry, this is IA0, and this is IA1, and this part is the IA2. Okay, this is IA2. So it's not difficult, right? Very easy. Just substitute all the values here and we finish. Okay, then we solve all the equation here, and finally we get this IA1 equal to EA over Z1 plus Z2 multiplied with Z0 over Z2 plus Z0. So this is the equation that we get for double line to ground. Let's refresh. Okay, for the case of SLG single line to ground, still remember, right? EA over what? Z1 plus Z2 plus Z0. For the LN1, LN line to line, line to line 4 is EA over what? Z1 plus Z2 only, no Z0. So, and for the case of, we call that DLG, DLG double line to ground, so EA over Z1 plus Z2 multiplied Z0 over Z2 plus Z0. So quite slightly longer than the both SLG and L, but still for me still forward. Okay, so when we're drawing the equivalent circuit, so it's the same basics, same basis to connect all together the three sequences, where this is zero sequence, this is positive sequence. Sorry again, my mistake, this is positive sequence, positive sequence, and this is negative sequence, and this is a zero sequence. So zero sequence again. So Z2 is negative, Z1 is positive. Sorry, because maybe because I'm too sleepy, so that's why little mistake is forgiven. Okay, so this is basically this is Z0, so this is Z0. You still remember, right? ZG0 plus 3Zn is the Z0. Okay, alright. So this is the sequence recognition for double line to ground. When you are asked to draw it, so this is how you draw it. Okay, right. Okay, let's proceed to the next example. So let's say we have the 20 MVA 30.8 undamped silent pole synchronous generator with the positive impedance, positive sequence impedance of 0.25, negative sequence impedance of 0.35, and a zero sequence impedance of 0.1. And then neutral is solidly grounded, and calculate subtangent fault current. Fault current means that, so the fault current is IF lah. Okay, IF. This is the thing that we're going to solve first. And line voltages. Line voltages too, maybe if you still remember when we learn from load flow, so line voltage may be AB, VBC, VCB, kind of that. So that is the line voltages. VA, VB, BC is not the line voltages, it's the phase voltage. Okay, phase voltage for this fault analysis. Okay. So as usual, first of all, we need to draw the positive sequence network, negative sequence network, and the zero sequence network, which both with all three values of 0.25, 0.35, and 0.1 respectively. And then from the equation that we have learned before, so IA1 equal to EA over Z1, Z2, Z0, Z2 plus Z0. And then I told you, because value is not given, so we just simply assume 1.0 plus J0 for the EA. And then we put the value of Z1, 0.25, Z2, 0.35, and Z0, 0.1. Same this one, same this one. Okay. Then finally we get the values of this problem. We get the IA1 equal to minus J3.0506 per unit. Okay. So after that, after we get the IA1, so after you get IA1, then we solve the VAO, which is the VAO equal VA1 equal VA2, like we have learned before in the theory part, where the EA minus IA1 multiplied with Z1. So we just simply substitute the value. This time I put only two decimals. So we solve A, we get the VA0 equal 0.237. Then after that, we need to solve the IA2 and IA0. So where the IA2 equal to minus VA2 over Z2, and the IA0 equal to minus VA0 over Z0. Then you just replace the value where the VA2 and the VAO is the same value, 0.237, 0.237. What does Z2? Put their own values here. Then you get the IA2 of J0.68 and the IAO equal to J2.37. So as we mentioned before, so IA equal to IAO plus IA1 and plus IA2 must be equal to equal to 0. So this is how we prove it. So here we have proven that the IA equal to 0. Okay. So finish. Then next, what should we do? So using the same matrix that we have learned many times over and over again. So this time where the IA equal to 0, then we solve all these things. Okay. And then where the IB, don't be panicked. It's just the multiplication from this matrix. So I2 A2 IA1 plus IA2 plus IA0. Then we simply put the A2 equals to this value and A equal to this value. Oh my god, what is this? I don't know this. We have not learned before. Actually, we have learned. Okay, if you still remember, A equal to 1 and the degree is 120 degree, and A2 equal to 1 equal to 240. So you just change it in the complex form, then you get the value. Just change, use your calculator and change it, you get this kind of thing. So with the A2 equal to minus 0.5 minus J 0.866, or you can refer other side of book. And then for the case of A on the negative 0.5 plus J 0.866, so we replace all the value of the IA1, IA2 and IA0, solve it, then we get the IB equal to 4.8 with the phase of 132.3 degree per unit. Next, what's next is IC. So just do the same matrix. Okay, same matrix. Solve it and you get the IC equal to 4.8 with the phase of 47.7 degree per unit. Then this is the main thing, which is this the fault current, but still is in the per unit. Okay, per unit. This one still in per unit. Okay, not percentage sigma, is per unit. Then which is the, also you can call as the, I have no problem if you write IF, which is the fault current. Okay, then equal to 3 IA0 or IB plus IC. Yeah? Okay, both will drive you to the same values. In this case, the fault current is J 0.11 per unit. Then next, we are going to change it in the voltage in the current. So you need to multiply with base, I base and V base. Okay. So we know already VA equal what? VA1 plus VA2 and VAO. But here we know already, everything is our head already. VA1 equal VA2 equal VA0. That's why it's equal to 3 VA1. So we just multiply it and we get J 0.711 per unit for the VA. And then after that, VB equal to VC. Already know this basic theory. Then this is what I call the line voltage. So this is the line voltage. So line voltage must be A to B, B to C, and C to A. Okay, right. So there's three. There's three of line voltage. Okay, because there are three buses, so we have three. No, three phase. Then we have three. So VAB equal to VA minus VB, which is the 0.711 per unit. Okay, per unit. And then where this one is 0. Okay, VBC, of course, because both are 0, that's why you get the 0. Then VCA, remember, because the VC is 0, that's why you get negative 0.77 per unit. Then after that, in amperes, so we're now solving the amperes, and also we want in the voltage, and the final answer must be between the amps and also volts only. Okay, here, so IB, we just multiply with the base current. Still remember how to write it? Okay, IB, I-base equal what? So MVA F over the VL root 3, which is the, here is 20 MVA. The question, and the base voltage is 13.8, and is the root 3. So we just get maybe around 836.7 blah 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 blah. So it's okay to get just take the value of 807 amps. So just multiply with the base current for all these three. Then you get the final answer all in amps. Okay, for 2017 with this phase same, and this one also everything same in amps. Okay, everything in amps. Then VAB just multiply with the base voltage here. Okay, which is the 13.8 over 3. then we get the value of kilovolts. And VBC we know already because 0 minus 0 is 0, so nothing. So by the VCA, because minus, just the minus here, where the phase is now changing, so the phase is changing now. Okay,